Understanding residual standard deviation. Residual standard deviation is a crucial statistical measure that plays a significant role in regression analysis, which is widely used to explore the relationship between variables. This article will delve deeper into what residual standard deviation is, how it is measured, and its implications in various fields, particularly in business and research. What is residual standard deviation? Residual standard deviation quantifies the variation in observed values compared to predicted values derived from a regression model. It addresses the discrepancies between actual and expected results, providing insights into the model's predictive power. In regression analysis, two primary types of variables are investigated: independent variables, predictors, and dependent variables, responses. The primary objective is to understand how changes in the independent variable influence the dependent variable, and residual standard deviation helps assess how closely the model's predictions align with real-world data. Key takeaways. Definition: Residual standard deviation represents the standard deviation of residual values, which are the differences between observed and predicted values from a regression analysis. Measurement of error: It serves as a measure to evaluate the error of predictions made by the regression model. A smaller residual standard deviation indicates a more accurate and reliable model. Goodness of fit: This measure is essential for assessing how well the regression line fits the data. It can help identify potential adjustments needed to enhance the model's accuracy. Importance of residual standard deviation. Residual standard deviation provides valuable insights in various applications. 1. Business forecasting. For businesses, understanding the residual standard deviation can offer a tangible view of how actual costs or sales might deviate from forecasts. For instance, if a business analysis indicates a low residual standard deviation for projected sales figures, management can be more confident in their financial planning. 2. Research validation. In scientific research, knowing the residual standard deviation aids in validating experiments. It informs researchers how reliable their predictive models are, which is essential when reporting findings. 3. Improving models. By examining residuals, analysts can identify patterns that suggest improvements in model specification, such as including additional variables or changing the model type altogether. Calculating residual standard deviation. Formula. Residual standard deviation can be calculated using the following formula. /s_res equals /sqrt /frac /sum y_est caret 2 n 2 \where /s_res equals residual standard deviation \y equals observed value \y_est equals estimated or projected value \n equals number of data points. Steps to calculate. 1. Calculate residuals. Start by computing the residuals, which are determined by subtracting the predicted values \y_est from the actual observed values \y \text residual equals y_est. 2. Sum of squared residuals. Calculate the sum of the squared residuals. 3. Apply the formula. Substitute the sum of squared residuals into the residual standard deviation formula and solve. Example calculation. Let's assume we have the following dataset with observed and predicted values. Observed values \y predicted values \y_est 1012 1514 2019 2524. 1. Calculate residuals. For y equals 10 y_est equals 12 residual equals 10, 12 equals dash 2 backslash. For backslash, y equals 15 backslash, y underscore, est, equals 14 backslash residual equals backslash, 15, 14 equals 1 backslash. For backslash, y equals 20 backslash, y underscore, est, equals 19 backslash residual equals backslash, 20, 19 equals 1 backslash. For backslash, y equals 25 backslash, y underscore, est, equals 24 backslash residual equals backslash, 25, 24 equals 1 backslash. 2. Sum of squared residuals. Backslash. Minus 2, caret 2 plus, 1, caret 2 plus, 1, caret 2 plus, 1, caret 2 equals 4 plus 1 plus 1 plus 1 is equal to 7. Backslash. 3. Calculate residual standard deviation. Number of observations backslash, n equals 4 backslash. Backslash. S underscore, res, equals backslash sqrt backslash frac, 7, 4 to 2, equals backslash sqrt backslash frac, 7, 2 backslash approximate 1.87. Backslash. Therefore, the residual standard deviation for this dataset is approximately 1.87. Conclusion. Residual standard deviation is a vital statistic in regression analysis for determining the reliability of predictions based on observed data. Understanding its calculation and application can greatly enhance data analysis and forecasting capabilities in various domains, making it an indispensable tool for analysts and researchers alike. By continually examining the residuals, we ensure that our predictive models remain robust and relevant.